segment. Thanks, Twitch subscribers, etc. Twitch.tv/smAsho is the location. Let's do it. Before we do the cosmology segment, again, check out twitch.tv/smAsho. We stream live regularly to that. Thanks to our new YouTube subscribers. Thanks to our old YouTube subscribers. Thanks to our friends and foes and neutrals for tuning into the video. Cheers. We're also on BitChute. Check out exclusive content there. We're counting down to the solstice. It's not really part of the cosmology segment. We're just advertising the fact that we're going to be streaming live at 11:32 and 9 seconds. That's 11:32 p.m. Eastern Daylight Time at the moment of the solstice. June 20th, 2021. I'd like to welcome all of our viewers to the Neo Renaissance, as all sorts of things are being rewritten when it comes to things like astrophysics, cosmology, heliophysics, and so on, to the point where we've created some themed merchandise. So check out the Smash store. You can find it at our homepage. The Smash store features the Condensed Matter shirt. Condensed Matter matters. And we've put up a high-resolution image here of the sun in 304 angstroms ionized helium and a lattice structure which lies underneath that underlying structure of stars. Yes, they're likely made of superionized materials. Next, I'd like to thank our superionized Patreons. Thanks, patrons, for increasing the probability that these videos will continue to exist, remain publicly visible, and expand in their sort of sophistication and, if you'd like the earliest information about things like coronal mass ejections and so on, consider becoming a patron at patreon.com/smAsho. So our first article that we're going to cover today is never before seen detail at the center of our galaxy. So there's a lot of stuff going on at the core of the Milky Way galaxy. There are supermassive hot stars orbiting the galactic core, one of which, S2, we'll talk about in a minute, has a periodicity of only 16 years. It's traveling at about 11 million miles per hour, and we'll show you more data on that in a moment. I'm just letting the article scroll here so you can read it if you like. Feel free to pause the video. It's the beauty of video on demand. We'll be here when you come back. And it's talking about things like the magnetic field environment at the core of the galaxy, the energy outflow, and so on. And let me just take a moment to show you a little animation here. Now that is what's going on at the galactic core. So the blue dot in the middle of that image there, that is Sagittarius A star. That is the point at which the other objects appear to be orbiting. We don't see very much emission from that, although it is a powerful radio source and X-ray source. And it's because there's a lot of dust and gas and other stars obscuring what's going on at the core of the Milky Way galaxy. Let me get that off the screen and put this article back up. So there's the busy environment going on at the core of the galaxy. Now today we're not going to talk about any random numbers. We're going to talk about S2. So S2 is the star located in the star cluster close to the radio source Sagittarius A star. It's believed to be about, I believe it's 15 solar masses. Nope, it's only believed to be about, just a minute here. S2 is believed to be at a mass of, the dangers of streaming live. 10 to 15 solar masses is the expected mass of S2, and a little bit about its orbital characteristics. It's got a highly eccentric orbit with an orbital eccentricity of 0.88, and it's traveling at its fastest point. It's able to reach speeds exceeding 5,000 kilometers per second, much faster than a typical solar wind speed that we would see, 1/60th the speed of light, or 11 million miles per hour. Anyway, the point is, what's going on at the core of the Milky Way galaxy is quite complex. And indeed, in the rest of the spiral arms, it's quite complex as well. More on that in a minute. First, the astronomy picture of the day. It's a total lunar eclipse. And this one does appear to be the one that just occurred on the 26th. So lots of stuff going on in space. That's why we cover it on the regs. Allow me to get off screen. And here's the environment going on at the core of the Milky Way galaxy. So you can see, first of all, I would note this right here, Sagittarius A star, Sagittarius A star is the area around which, it's the radio source around which all of these massive stars seem to be orbiting. I would also note this X-ray filament right here. And this is part of the focus of this article. G0.17-0.41 is this X-ray filament. There's also a cold gas cloud in there and various other features, such as Sagittarius C. And so check out this article, also in the phys.org's Astronomy and Space section. Magnetized threads weave spectacular galactic tapestry. Now, there is some argument here. It's a chicken or the egg argument. Is the dust perpetuating the magnetic fields, or are the fields causing the dust to be oriented the way that they are? I won't get into it in this video, but feel free to read the article, as I am a believer that the dust and gas is orienting to the fields because the fields are there because of the intrinsic nature of the stars that are producing them. So in any case, this is pretty important, and here is a fantastic composite image. The composite image of the Chandra X-ray telescope and the Meerkat radio data. So on this one, what you're looking at is in pink. That is the Chandra X-ray telescope's data. And in blue, that is the Meerkat radio data. So fantastic imagery of all of these largely parallel filaments. You can see a lot of these filaments are parallel here, or roughly parallel. Perhaps also giving us additional insight into what is going on at the core of the Milky Way galaxy. I can tell you this, what's going on in the core of the Milky Way galaxy is absolutely nothing like what's going on in the solar system. And that's today's Cosmology segment. We'll have to say goodbye to Twitch. We'll bring you back for the Meteorology segment.